Welcome to The Explainer. Today, we're going to unravel the story of the internet. It's this technology that was born from Cold War paranoia, but it was built by idealists, and then it just accidentally got unleashed and changed, well, everything. It's this incredible tale of brilliant minds, some happy accidents, and a dream of connecting all of humanity that just grew way beyond what anyone could have imagined.
So the big question is, who invented this thing? Who do we think? Now, if you're picturing some single inventor, a lone genius in a lab like a modern-day Edison, well, you're in for a bit of a surprise. The real story is, it's so much messier and honestly, way more interesting.
The truth? No one person invented it. And, in a way, everyone did. See, the internet wasn't some single aha moment. It was an evolution. Think of it like a giant patchwork quilt of ideas, stitched together over decades by all these different scientists and researchers, sometimes competing, sometimes collaborating, all over the world. Each one of them added a critical piece to the puzzle. It's really a story of problem solving on a global scale.
All right, so here's our game plan for today. We're going to start with those Cold War fears that kicked the whole thing off. Then we'll trace how the first actual networks were built. After that, we'll see how they all learned to speak the same language. And then, boom, we'll watch how it just exploded into the public and became the web we all use every single day.
Okay, so our story kicks off in a world that felt like it was teetering on the brink of nuclear war. We're talking the late 50s. The US military had this terrifying question they were trying to solve. If the absolute worst happens, if our communication hubs are just gone, turned to ash, how do we command anything? They needed an answer, and that answer was a network. A network so tough, so resilient, it could survive the unthinkable. Basically, a network with no center, no single point of failure that could be taken out.
But here's the cool thing. While the military's over here planning for doomsday, you've got this visionary computer scientist, a guy named J.C.R. Licklider, and he's dreaming of utopia. He's imagining what he called an intergalactic computer network. I mean, how cool is that? A future where information was just freely accessible to everybody. It was pure sci-fi back then, but that dream, it's what inspired a whole generation of researchers to build the exact tools the military was looking for.
So, the absolute genius idea that made all this possible was something called packet switching. And get this, it was developed at pretty much the same time in the US and in the UK. It was just a revolutionary concept. The old way was a single, vulnerable phone line. With this new idea, you chop up your message into these tiny little packets of data. A great way to think about it is like tearing a book into 1,000 individual postcards, mailing each one separately, and just letting them find their own way to the destination, where they get put back together. It sounds like chaos, right? But it's organized chaos.
And this is where you really see the radical difference. The old phone system, think of it like a railroad track. It's a single, dedicated line. If a bridge is out, well, that train is stuck. Game over. But packet switching, it's more like a whole fleet of delivery drones. If one route is blocked, no big deal. The other packets just find another way around it. It was the perfect solution for a network that had to be able to survive pretty much anything.
Okay, so the theory was there. It was brilliant. Now it was time to actually build the thing. And that's where the U.S. Defense Department's Advanced Research Projects Agency, or ARPA for short, comes in. They put up the money for an experiment to make this wild idea of a packet-switched network a reality. And they called it ARPAN.
So the big moment comes. It's October 29th, 1969. You've got a team at UCLA trying to log into a computer all the way at Stanford. They actually had a phone line open just to confirm it was working. So the guy at UCLA types L. The voice on the phone from Stanford says, "Yep, got the L." Awesome. He types O. "Yep, got the O." He types G, and the whole system crashes. So the very first message ever sent on the internet was low. You can't make this stuff up. It was a total fail, but at the same time, it was a giant leap.
And, it's really important to remember, ARPANET wasn't the only game in town. Not by a long shot. You had similar projects bubbling up all over Europe. Over in the UK, the NPL network was also pioneering packet switching. And in France, you had a network called Cyclodeds that was developing these ideas that would end up being hugely influential down the road. So this really was a global effort. You had all these brilliant ideas just bouncing back and forth across the Atlantic.
So, all this innovation was amazing, but it created a brand new problem. You've got ARPANET over here, the NPL network over there, Cyclades somewhere else, and they were all like separate little islands. They were built on different rules, different principles, and they just couldn't talk to each other at all.
The challenge then was, how do you connect these islands?
How do you build a network of networks? Which, by the way, is where we get the term internet work, or internet. What they needed was a universal language, a kind of digital Esperanto, a set of rules that every single network could agree to use, so a message could just hop from one network to the next and arrive at its destination without a hitch.
And the solution came from two ARPANET veterans, Vince Cerf and Bob Kahn. And it was brilliant. They developed a pair of protocols called TCP/IP. Here's a great way to think about it. TCP, that's the super meticulous organizer at the post office. It takes your big package, chops it up into standard-sized boxes, numbers every single one, and then makes sure they all get delivered and put back together in the right order. Then you have IP. IP is the mail carrier. It doesn't care what's in the boxes, it just reads the address on each one and figures out the best route to get it where it's going. Simple, elegant, and it worked.
And this all leads us to a really pivotal moment. January 1st, 1983. It's a day that's known as Flag Day in the tech world. This was the day that ARPANET officially flipped the switch and started using TCP/IP. It was the moment that all those separate little islands, those different networks, finally started speaking the same language. You could argue this was the day the internet was truly born.
Okay, so by the 80s, the internet is a real thing. It exists, but it's this super exclusive club. It's just for academics, researchers, and the military. If you wanted to use it, you had to type these cryptic commands into a black screen with green text. It was powerful, for sure, but it was not user-friendly. It wasn't for regular people. But that was about to change in a huge way.
So, flash forward to 1989. You've got a British computer scientist named Tim Berners-Lee, and he's working at CERN, the big particle physics lab in Europe. And he's just trying to solve a practical problem. He wanted a better way for all these scientists to share their research papers and data. So he proposed a system based on three core ideas. 1. A universal addressing system, so you could find any document, that's the URL. 2. A simple language to write them in, that's HTML. And 3. A way to link them all together, that's HTTP. And just like that, the World Wide Web was born.
Now, to really get the impact of the web, you just have to look at the numbers. Think about this. In 1981, before TCP/IP was even the standard, there were only about 213 computers, or hosts, connected to the ARPANET. That's it. 213. It was a tiny club.
Now, let's fast forward to 1990. The web is just starting to emerge, and that number, it had absolutely skyrocketed to over 300,000. What changed? The web gave the internet a friendly face. It gave it a graphical interface that anybody could just point and click their way through. It was the key that finally unlocked the internet for the rest of us.
And the takeover was just breathtakingly fast. Look at this. In 1993, the internet was carrying just 1% of all the information flowing through telecom networks. Just 1%. By the year 2000, it was over half. And by 2007, it was more than 97%. The web didn't just, join the media landscape, it became the landscape.
So that first version of the web, Web 1.0, was mostly a read-only kind of deal. It was like a huge digital library where you could look stuff up. But the next big shift, well, that turned it from a library into a massive global conversation.
And this really captures that shift to what we now call Web 2.0. The internet went from being that read-only library to a read-write town square. We went from being passive consumers of content to being active creators. Think about it. Instead of just reading an encyclopedia, we could all write one together on Wikipedia. Instead of just browsing sites, we were blogging, we were sharing. We were building entire communities on places like Facebook and YouTube. The internet became a platform for our voices.
Which brings us to a really fundamental, kind of crazy question. You've got billions of users, countless networks all connected. So who's actually in charge of this whole thing? And the surprising and kind of cool answer is nobody. And also, everybody.
Yeah, there's no CEO of the internet, no president. Instead, what you have is this decentralized system of, governance. You've got groups like the Internet Engineering Task Force, the IETF, which is basically made up of volunteer engineers who figure out the open technical standards to make sure everything can still talk to each other. Then you have organizations like ICANN, and they coordinate the critical address books of the internet. The domain names and IP addresses, so your data actually gets to the right place. It's a whole system built on what they call rough consensus and running code.
But here's the twist.
That very openness, that's now its greatest challenge. The web's own inventor, Tim Berners-Lee, has been warning for years that his creation is at risk. He's worried about misinformation, about polarization, about the incredible power that a few giant tech platforms now have. The very principles of openness that built the web in the first place are now seriously under threat.
And that really leaves us with a critical question for our time, doesn't it? The internet started as this experiment in resilience, and it grew into this incredible global commons for information and connection. But as it gets more and more central to, well, everything, our economies, our societies, can we actually preserve that open, decentralized spirit that made it so revolutionary to begin with?
You know, the story of the internet is still being written, and the truth is, we are all a part of writing that next chapter. Hey, if you enjoyed this little journey through history, you should definitely check out our explainer on the printing press. It's another story of how a single technology just completely changed the world. And of course, don't forget to subscribe for more deep dives. Thanks so much for watching.